Welcome to Lesson 9.4, Part 2, Area of Composite Figures. Today we're going to talk about finding the area of composite figures and solve problems involving the area of composite figures. First, we have to understand what a composite or complex figure is. This is not in your vocabulary, so you do not have to write it down if you don't want to. A complex figure is a figure that can be split into simpler shapes. In this case, when we talk about simpler shapes, we talk about the shapes that we already know how to find the area of. In this case, we know how to find the area of rectangles, triangles, and parallelograms. So when we look at a shape, we want to split it into those types of shapes. When we do this, however, we can only draw from vertex to vertex. So when we do this, there's two different ways that you can split this shape. We could start here and go across and go from vertex to side and make our own vertex. That's okay. Or go vertex to side this way and make another vertex. I know that we are looking at it saying we could go from here to here, but we don't know how to find the area of trapezoids, and that would make the figure way too complex to figure out. So we make it easy on ourselves by making two separate rectangles, because the formula for the area of a rectangle is much simpler than the formula for the area of a trapezoid. Right, so let's try this. If you take a look at this shape, I want you to look, pause, see if you can find where you would split this shape apart. Alright, when you split this shape apart, you can go from corner to corner near the top and split it into home and attic, or more specifically, a rectangle and a triangle. Now you need to remember the area formulas for each. The area formula for a rectangle is base times height, and the area formula for the triangle is half times the base times the height. Now we plug in our numbers, and in this case, the base is 10, and the height is 8. And in this case, the base is 8, because from here to here, it's still going to be 8 centimeters. Same here is the same here. And we get 3 centimeters because the height of the entire shape is 13 centimeters, but we use 10 of those centimeters to go from this side to our new side. Okay? So we only have 3 centimeters left to use as the height of our triangle. So the area formula here would be half times 8 times 3, which would leave us with 4 times 3, which would leave us with areas of 8 square centimeters and 12 square centimeters. In order to find the total area, we take 80 that we got from the rectangle and the 12 that we got from the triangle, and we add them together, and we get 92 square centimeters. Alright, so we have this figure. There's two ways to break apart this figure, so I will show you both. So if you break apart the figure differently, just wait patiently, and we can show you the different version afterwards. Okay, so go ahead and pause and split it on your own. When you come back, I'll go over both examples. Alright, in this case, we split the rectangles into two smaller rectangles. This allowed us to keep all of our dimensions. We were able to keep a height of 4 9/10 centimeters and a base of 1 7/10 centimeters. We didn't have to look for anything or do any math to find anything else. Then we were able to keep 1 3/10 centimeters as the base here and 2 1/10 centimeters as the height there. So we have a base of 1 7/10 centimeters times the height of 4 9/10 centimeters. And for rectangle number 2, we have a base of 1 3/10 centimeters times 2 1/10 centimeters. We go to the side, we can practice our multiplication with decimals. Okay. 9 times 7 is 63, carry the 6. 1 times 9 is 9, plus 6 is 15. Okay, since we're done with the 9, we place a 0 here. 7 times 4 is 28. Carry the 2. 1 times 4 is 4, plus 2 is 6. If we add these together, we get 3, 13, 6, 7, 8. But because we have two numbers after the decimal, we move our decimal 2 places to the left. The area of the first rectangle is 8 and 33 hundredths centimeters squared. And over here, we'll practice 1 and 3 tenths times 2 and 1 tenth. 3 times 1 is 3. 1 times 1 is 1. 0 is a placeholder because we're done with multiplying with the 1. 3 times 2 is 6. 1 times 2 is 2. If we add these together, we get 273, but we have two numbers after the decimals, so we move our decimal 2 places to the left, and we get 2 and 73 hundredths centimeters squared. Again, we add the two areas together, because when we put the two shapes together, they cover that much area. 3 plus 3 is 6. 7 plus 3 is 10, carry the 1. 8 plus 2 is 10, plus 1 is 11. And with adding, we bring our decimal straight down. So the area of this complex figure is 11 and 600ths centimeters squared. Now I know some of you might have done this a little bit differently and broken up the shape this way from here to here. And that's fine. We just have to do a little bit more computing with this because it gives us rectangle 1, which is here, and rectangle 2, which is here. Okay, rectangle 2 does have a base of 3 centimeters. It shows you here. This and this have to be congruent. So this is 3 centimeters. And the height of this rectangle is still 2 and 1/10 centimeters. So that isn't any different. However, this rectangle, rectangle 1, does change because the height is no longer 4 and 9/10 centimeters. Now, since this over here is 2 and 1/10 from here to here, we have to take the total 4 and 9/10 and subtract the 2 and 1/10. We take 9 minus 1 is 8. 4 minus 2 is 2. We bring the decimals straight down. We have a height of 2 and 8/10 centimeters and a base of 1 and 7/10 centimeters. Other than that, the process is the same. We take the area of rectangle 1 and the area of rectangle 2, find them, and then add them together. So rectangle 1 had a base of 1 and 7/10 and a height of 2 and 8/10. And rectangle 2 had a base of 3 centimeters and a height of 2 and 1/10 centimeters. So I'm going to go off to the side, take my 1 and 7/10, multiply it by 2 and 8/10. 7 times 8 is 56. Carry the 5. 1 times 8 is 8, plus 5 is 13. We're done with the 8, so we put a 0 as a placeholder. 7 times 2 is 14. Carry the 1. 2 times 1 is 2, plus 1 is 3. We add these together, we get 6. 3 plus 4 is 7. 1 plus 3 is 4. We have two numbers after the decimal, so we move our decimal 2 places to the left. The area for rectangle 1 is 4 and 76 hundredths centimeters squared. For rectangle number 2, we take 2 and 1/10 times 3. 1 times 3 is 3. 6 is 2 times 3. So we move our decimal 1 place to the left. 6 and 3/10 centimeters squared is the area of rectangle number 2. And last but not least, we have to add the two areas together. So rectangle 1 plus rectangle 2. So we can add a 0 here. 6 plus 0 is 6. 7 plus 3 is 10. Carry the 1. 4 plus 6 is 10. Plus 1 is 11. Bring your decimals straight down. And we got the area of 11 and 600 centimeters squared, which if you look is the exact same answer as we got up here. Same answer, just two different ways. Right? So now you have the opportunity to give this a shot on your own. I want you to post your answer to Edmodo. I want you to first tell me what shapes did you break it into. And then the second, give me the area of the entire shape. Okay, you can do this as one post. So for an example, you would say here, so for this one, your post would be 2 rectangles, and then your area was 11 and 600 square centimeters. Right, so that's what I want you to post for this one on Edmodo. If you have any questions, make sure to post them or come ready with them for tomorrow's class.